Welcome to this second lesson on computer architecture. So today we are going to focus on how the CPU fetch, decode, and execute instructions. So introduction: the process by which a CPU fetches, decodes, and executes instructions is known as the instruction cycle, or the fetch, decode, execute. The fetch, decode, and execute cycle. This is the basic cycle that all modern CPUs follow to process instructions and execute programs. This process can be broken down into the following stages. The first one is the fetching the instruction. So you have the program counter, that is the PC. The process begins with the program counter, a special register that holds the address of the next instruction to be executed in the memory. The program counter points to the location in memory where the next instruction is stored. We also have the fetching. The CPU sends the address in the program counter to the memory unit, which retrieves the instructions from memory, typically RAM. This instruction is fetched and placed in a temporary holding register called the instruction register. So have the incrementing the program counter. So as you can see, it talks about after the instruction is fetched, the program counter is typically incremented or to bracket adjusted to point to the next instruction in memory. So have the decoding the instruction. So under the decoding instruction, you have the instruction register, and you have the control unit. We have the opcode, that's the operation code. We have the operands, the control unit. So the control unit generates control signals based on the decoded instruction. These signals will direct other parts of the CPU like the ALU, that's the arithmetic logic units, registers or memory, on how to handle the operation. Sorry. We also have the executing the instruction. So for that one, and that is the execution by the ALU, memory access, that's if required, and register transfer. We also have the writing back the result, that's if necessary. So in some instructions, the result of the execution must be written back to register or memory. For example, in an arithmetic operation, the result may be written back to a register. In a store operation, the result is written to memory. The control unit manages this process by issuing signals that direct the CPU to store the result in the correct location. So how they repeat. So for the repeat, that is the program counter, the fetch. So like the program counter, that is which was updated earlier to point to the next instruction. Now point to the next instruction to be fetched, and the cycle repeats. This cycle continues until the program finishes or encounters an instruction that causes the CPU to stop. Example, an halt instruction. Summary of the steps. So the fetch, the instruction is retrieved from memory using the address in the program counter, that is the PC. Decode, the instruction is decoded by the control unit, which generates control signals to specify what operation needs to be performed. Execute, the ALU or other part of the CPU execute the instruction, performing calculations or memory access. Write back, if the instruction requires storing a result, the result is written to a register or memory. Repeat, the process repeats for the next instruction. So key components involved in this topic are the program counter, the instruction register, control units, the ALU, that is the arithmetic logic unit, memory, and registers. So example walkthrough. For an instruction like add R1, R2, R3, where the goal is to add the content of R2 and R3 and store the result in R1. So for the first step, that is the fetch, the CPU fetches the instructions from memory got a PC point, storing it in the internal register, that is the IR. Um, the control unit decodes instruction. It defines the opcode, that is the operation code, and determines that it needs to add the content of registers R2 and R3. So execute. The ALU performs the addition of R2 and R3. The write back the result of the addition is stored in R1. Repeat, the PC is incremented and the next instruction is fetched. This cycle is continuous and forms the backbone of how the CPU processes programs, turning sequences of instructions into actions. Thank you all for watching this video. Stay tuned for more.